3, and only 3 classes of lever. Let's learn physics. Here is a basic lever setup. You have a fulcrum, you have a place for the input force, and the location for the output force. So there are 3 things. And here are 3 things also. And there are only 3 ways in which you can put these things. I can put the big black one in the middle, I can put the shiny one in the middle, or I can put the little brassy one in the middle. That's why there are 3 classes of lever. Here's the first one. First one's a simple teeter-totter. You got the fulcrum somewhere in between. This is going to be the output force, or the location of the output force. That's the thing I'm lifting. And here is the location of the input force. Always identify a first-class lever by the fulcrum being between the input and output forces. I push down, it lifts up. Simple first-class lever, fulcrum between. First-class lever is always a direction changer too. You push down, it pushes up. Doesn't have to be in the middle as in like the center. You can take this thing, put it in there, and oh, wow, that's easy. This is how we do the calculation for ideal mechanical advantage. You take the input lever arm divided by the output lever arm. There's the equation. The input lever arm and the output lever arm are both always measured from the fulcrum. So that's what it looks like for the first class lever. It's the same thing as the ratio of input displacement versus output displacement, but that's inconvenient to measure. We can just measure the input lever arm over the output lever arm. It's pretty easy to do. This is clearly a force multiplier. Fulcrum's closer to the output force in this case, so the input lever arm is longer, so the mechanical advantage is greater than 1. So there's always a trade-off in all these machines. In this case, I get a larger force, and now even a larger force. It's super easy to do, but notice how little this one lifts and how much that one moves. Any force multiplier like this one, always going to be, unfortunately, a speed displacement divider. Small force over a large displacement, input, gives me a large force, but only over a small displacement, force multiplier. Here's that same idea in symbols. Larger size output force, smaller size output displacement. If I switch those two, take this, put it over here, just switch them, imply the input force here, and it's very difficult to do. It's quick. But notice, I'm applying a large force and requires a whole lot of effort, but I get a whole lot of motion. This is a speed and displacement multiplier. And that's generally true for all machines. Switch the input and the output, make a force multiplier into a speed displacement multiplier. And to show that more effectively, you can take this, move it over there, and move this fulcrum. Doesn't have to be in the middle, you can put it anywhere you want. And watch what happens here. Large force, and it's difficult to get it to move, but it does move a lot. It's a really good speed and displacement multiplier, but it requires a huge amount of force. Always the trade-off. First class lever, fulcrum between the input force and the output force. So remember, first class lever is identified by seeing the fulcrum in between the input and the output forces. Lever arm is always measured from the fulcrum. The mechanical advantage is always the input lever arm over the output lever arm. And for the first class lever, you could have a greater than 1 or less than 1 or equal to 1 mechanical advantage. In a situation like this, the input lever arm is larger, greater than 1 mechanical advantage, that's a force multiplier, but it's unfortunately a speed displacement divider. Situation like this, the mechanical advantage is less than 1 because the output lever arm is larger than the input lever arm. That is a speed displacement multiplier, and unfortunately a force divider. In the last situation, if the mechanical advantage is equal to 1, the lever arms are equal to each other, and that's only a direction changer. And by the nature of our universe, the law of conservation of energy, no machine can multiply both speed displacement and force, just one or the other. Second class lever, the output force is in between. So you get the fulcrum on one end, input force on the other end, and this thing somewhere in between. Second class lever is identified by looking for that output force in between the input force and fulcrum. If I send it out here, it's like a wheelbarrow. If you have a wheel right here, that acts as not only the pivot but also the the wheel, to move it forward. I am the artist, and that is my rendition of what many people around here call a wheelbarrow. You can lift a pretty heavy weight by lifting out here with a relatively small force. And you can tell just by looking at it, oh, that's a larger motion over there at the input, smaller motion at the output. It's a speed and displacement divider, therefore it must be, just by looking at it, a force multiplier. If you see it dividing speed or displacement, it's got to multiply force at the same time. You can make it better by doing that. Oh yeah, that's easy. Now, that's easy. And you can also make it worse by doing this. It's not as good of a force multiplier. That's not as good of a force multiplier, but it still is. And the lever arms that you're measuring are the fulcrum to force. That longer lever arm is the input. And the fulcrum to force, that lever arm is the output. Second class lever, identified by looking for the output force between the other two. Looks like a wheelbarrow. Remember, you're always taking the input lever arm divided by the output lever arm. And in this case, the input lever arm will always be longer because the output force is in between. So the mechanical advantage will always be greater than 1. So this second class lever will always be a force multiplier. And unfortunately, a speed displacement divider. Third class lever, fulcrum on one end, output force on the other end, input force somewhere in between. Look for it. It feels ridiculous, but this third class lever, the input force is always between the output force and fulcrum. So that requires a bunch of force, but you notice that speed and displacement multiplier, that thing moves a whole lot more. You can make it a better speed and displacement multiplier by doing this. So wherever my input force is at my finger, it's moving less, but requires a lot more force. Because more and more difficult to lift that. Input force is always between the two. So the input lever arm is always going to be shorter. And since you calculate input lever arm divided by output lever arm, the mechanical advantage of a third class lever will always be less than 1. It's always going to be a speed displacement multiplier. And, unfortunately, a force divider. This right here, even in closer, becomes really difficult to lift it. And that a really good speed and displacement multiplier. And if you disconnect it, you can see how good of a speed displacement multiplier it is. But just, it moves that end where the output force is, or the output is moving a whole lot more. And you can get a very similar thing from this. Oh yeah, so you can attach here, first class lever, because the fulcrum's in between. This is a really good speed multiplier. This is also a really good speed multiplier. So depending on the situation, you can get a mechanical advantage much less than 1 and get a really good speed and displacement multiplier by pushing here, watching the motion there, or pushing here and watching that motion there. So a first and third class lever can be very similar in operation. First and third class levers are both represented here in your arm system. You have the elbow on the back of your arm and this elbow protrusion. That is for the tricep attachment, speed and displacement multiplier to it's the extensor. The purple input force on the left is your tricep. Purple output force is the force at your hand. This is a speed displacement multiplier. And this little mini excavator is the same thing. It's a big long arm. Muscles and the bicep attachment that you can feel the tendon in there, that attachment is in front, and so the up force there, that is a speed and displacement multiplier. That is your arm. Bicep is the red input force on the left and the corresponding output force in red at your hand. This again is a speed and displacement multiplier. That is a third class lever. And all three classes of lever might be represented here, but your muscles and these hydraulic muscles are capable of really large forces, but only over short distances. So they are speed displacement multipliers. And here is your summary of levers. Remember that the IMA is calculated by the input lever arm over the output lever arm. First class lever, fulcrum is in between. And because you can slide that fulcrum back and forth between the input force and output force, you could have greater than 1, less than 1, or equal to 1 mechanical advantage for a first class lever. Identify the second class lever by looking for the output force in between. It's like a wheelbarrow. Lever arms always measured from the fulcrum and they overlap. Your second class lever, always a force multiplier. Mechanical advantage, always greater than 1. Unfortunately, a speed displacement divider. Identify the third class lever by looking for that input force between the other two. The mechanical advantage will always be less than 1. Lever arms overlap, so this thing's always going to be a speed displacement multiplier. Feels like it's really dumb, because you have to apply a large force to it, but you get a lot of speed and displacement out, and that's the goal.